All right, so on to objective 3, where we want to graph the cosecant function y is equal to cosecant of x, and the secant function y is equal to secant of x. So cosecant and secant, which are known as the reciprocal functions, have values that equal the reciprocal of the corresponding values of sine and cosine, respectively, because we know that cosecant is the reciprocal of sine and secant is the reciprocal of cosine at a given number x. So if the value of sine and cosine is 0, then cosecant and secant will be undefined at that value. So once again, we're going to have places where cosecant and secant are going to be undefined. So similarly to tangent and cotangent. This means that the graph of cosecant will have vertical asymptotes at each integer multiple of pi, and the graph of secant will have vertical asymptotes at each integer multiple of pi over 2. So when we look at our graph here, when our first graph being y is equal to cosecant of x, what we see is that we've written y is equal to sine of x in black, and then cosecant of x is then in blue. So it's the reciprocal. So where we have sine of x in each one of these intervals, we have parabolas essentially as cosecant of x. And same thing for y is equal to secant of x. So with y is equal to secant of x, we've drawn out y is equal to cosine of x in black, and so we see in these intervals, secant is then represented by these parabolas within the interval. So this is what the graphs of cosecant and secant would then look like. So objective 4, we want to graph the functions of the form y is equal to a cosecant of omega x plus b, and y is equal to a secant omega x plus b. So the role of a in cosecant and secant functions is to set the range in a specified period. So that's a capital A, so the amplitude. So the range of y is equal to cosecant of x would then be, and once again, we see the set builder notation where we have y and then we state a property of y. So the range is y, where y is now going to be less than or equal to the negative absolute value of the amplitude, or y is greater than or equal to the absolute value of the amplitude. So because of the vertical stretch of the factor of the absolute value of the amplitude. So really what we're seeing here with the range is that we have the values of the amplitude, either the negative or positive version of the absolute value of the amplitude, and then we're seeing that our range exists less than the negative value and greater than the positive value. And we're not saying that the range is going to be one or the other. The range is always that. So it's always that statement of y less than or equal to negative absolute value of the amplitude, or y is greater than or equal to the absolute value of the amplitude. It's always both. It does say or, and that's because in different periods we do see that our parabolas will alternate and whether they face upwards or downwards, but we have to consider both values. So when we write out our range, we do have to include both of those inequalities, and we have to write or. So it's not that we do write one or the other, we always have to write both. So just like with sine and cosine, the period of y is equal to cosecant of omega x and y is equal to secant of omega x is still going to be 2 pi over omega. So before we only had pi over omega, now we have 2 pi over omega. Then lastly, b indicates a vertical shift once again, which we're going to use our key points, so that vertical shift will come into play at about step 3. So, all right, example 2, we want to graph y is equal to 2 cosecant of 3x minus 2 and determine the domain and the range. It is a plus 2. I apologize for that. Y is equal to 2 cosecant of 3x plus 2. So we're going to go ahead and graph this using our key points. So just as before, I'm going to go ahead and do step 1. So step 1, we want to find the amplitude. which in this case is 2. So we're taking the absolute value of 2, which is just 2. And then we want to find the period. So our period is 2 pi over omega, which in this case is 3. So our period is now going to be 2 pi over 3. I clearly didn't update my notes on this. I'm sorry once again. This is a 4 and not a 3. So it's y is equal to 2 cosecant 4x plus 2. So it's not going to be 3. Having a period of 2 pi over 3 is going to be quite a bit more difficult than if we had 2 pi over 4, which then just simplifies 2 pi over 2. So, all right, this is our equation moving forward. I don't know. I must have been tired. So this is our equation moving forward. We have this 4 instead of a 3 and a positive 2 instead of negative 2. So moving on to our step 2, we want to go ahead and set up our intervals. So we know that our intervals have to be in the length of our period divided by 4. So we'll have pi over 2 divided by 4. So the lengths of our intervals are going to be pi over 8, once again. So our intervals here are going to be 0 to pi over 8, pi over 8 to pi over 4, pi over 4, there we go, pi over 4, to 3 pi over 8, and 3 pi over 8 to pi over 2. All right, so these are our sub-intervals. And we're going to go ahead and go into step 3, which we'll do down here again. So if we pick our x values, this means that our x values should be 0, pi over 8, pi over 4, 3 pi over 8, and pi over 2. But just like in our last example, we see that cosecant is not going to be defined on 0. Oops, sorry, pi over 4 and pi over 2. So we see there's 3 values that this is going to be undefined. So we see that it's not defined at 0, pi over 4, and pi over 2 because we are compressing our function by a factor of 4. So we're compressing by a factor of 4, which means that originally our graph of sine we see here has values of 0 when x is equal to pi, x is equal to 0, 2 pi, negative 2 pi, things along those lines. So we see that this is where we have our vertical asymptotes. But what we did was we compressed by a factor of 4, which now means that we're going to have undefined values at 0, pi over 4, pi over 2, 3 pi over 4, 2 pi, and so forth. So we have a lot more vertical asymptotes. So we see our functions are not going to be defined on 0, pi over 4, or pi over 2. So we just already know that they're going to be undefined, so we won't use them in our key points. This only leaves 2 values left, but that's okay because as we see in our graph here, we only needed 2 to really represent those 2 different parabolas that will help us determine the range. And we only need 1 point. Since we know it's a parabola, we just need the minimum or maximum point. So when finding the y values, we want to use pi over 8 and 3 pi over 8. So we'll go ahead and find our y values. We have y is equal to 2 cosecant of 4 times pi over 8, and then plus 2. So 2 cosecant of 4 times pi over 8 gives us pi over 2 plus 2. Cosecant of pi over 2 is going to be 1. So we really just have 2 times 1 plus 2, which it really just simplifies down to 2 plus 2, which is 4. So we'll zoom out a little bit. This means that our key point is going to be at pi over 8 and 4. And now we just have one more key point. So we have y is equal to 2 cosecant. Oh, now we have 4 times 3 pi over 8 plus 2. So we have 2 cosecant of now 3 pi over 2 plus 2, where 3 pi over 2 is going to end up being -1, so we have 2 times -1 plus 2. That's going to end up being -2 plus 2, which is just 0. So 3 pi over 8, 0. So these are our 2 key points. So let's go ahead and mark up our graph a little bit. We'll label all of our notches and whatnot, and then we'll go ahead and graph. So in our graph here, let's have this be pi over 8. We'll have this be pi over 8. There's really no reason to have a million intervals, so that'll be pi over 8. This will be pi over 4. So then we'll see this next value. This will be -pi over 8 here. All right. So we can go ahead and mark off our vertical asymptotes. So we have a vertical asymptote here at 0. And again, at pi over 4. So now we want to graph pi over 8 and 4. And I see we need to extend out our graph a little bit more here. So let's go ahead and do that. Let's go ahead and extend it like this. So that's pi over 4. Then we see this value here will be our 3 pi over 8. And then lastly, this will be pi over 2. So we have one more vertical asymptote. All right. So our first key point that we have here is pi over 8, 4. So we go to pi over 8, and we'll go up 4 because this is going to be 1, 2, 3, 4, 5, and 6. This will be -1, -2. So we go up to 4, and we make our point. And this value here, we can assume is going to be an upward facing parabola. We didn't have a negative that would indicate that this might be flipped. So according to our graph here, this first interval should be an upward facing parabola. We can also estimate this by saying as x is approaching 0, we will end up having 1 divided by a very small number, which would indicate having our values be going to positive infinity. Same thing then for pi over 4. We would see as x approaches pi over 4, our function of cosecant would look like 1 divided by a very small number. So that's also how we could determine that it is an upward facing parabola. But so we have our first point, and we can draw in our parabola. It will look something like this. And this is pi over 8, 4. And now we want to draw in our second key point. Our second key point being 3 pi over 8, 0. So we'll move this value up over here. So that's our point there. And since our last parabola was an upward facing parabola, this means that our next one will be the downward facing parabola. We can also figure this out by saying that as x is approaching pi over 4, but still slightly greater than pi over 4, this means that we will end up having values of 1 divided by a negative very small number. And so that would end up giving us a negative infinity for our function. Same goes for pi over 2. So that would be the other way that we figured out if it was going to be a downward facing parabola or not. But so we can go ahead and draw this in. Here, a downward facing parabola. And there we go. This would all we would need, this would be all we would need to figure out our range. If we wanted to draw in another period, we do have this value here. And copying what we had in this interval here, we can go ahead and assume that it will be another downward facing parabola that would end up looking something like this. So something along those lines. But all right, so we've gone ahead, we have graphed, let's go ahead. We've graphed out our cosecant function here. And the last thing we need to do is determine the domain and the range. So our domain is going to need to be in step builder notation once again. We see that our domain can't be defined at our, that's a 4. At our integer multiples of pi over 4. So when we write our domain, once again, our domain is corresponding to x, so we have x, where the property on x is that x cannot be equal to k pi now over 4, where k is an integer. So no integer multiples of pi over 4 is what we're seeing here. Then the range. This is what we talked about earlier, where we say that the role of a in our cosecant function was to help us set the range. So the range in y is equal to cosecant is y, where y is less than or equal to the negative absolute value of a, or y is greater than or equal to the absolute value of a. So this would normally give us our range, but we did have a vertical shift. So because of our vertical shift, we do have to change up our range a little bit more here. But really what we're seeing is that our range will be values greater than or equal to 4 or less than or equal to 0. So we have y less than or equal to 0 or y greater than or equal to 4. So that is how we would write it in our set builder notation. We can also write this in our interval notation, where we would write negative infinity to 0, but including 0, so writing that square bracket. And then we use this big U to indicate a union. So we're combining these two separate intervals. And then we include 4 to infinity. So that would be how we would determine our domain and our range of our function there. So, all right, that concludes our section for 6.5. So I'll see you again in the review for exam 1. So I'll see you all then.